All right, now we are going to be working on estimating derivatives of a function at a point. We actually did this a little in that last example in our last video where we had to find the mins and maxes. Let me show you. Here, we did this a little bit because we found the value of the derivative at these 2 points. But we're going to do that in a little bit more detail now. Okay, so to do this, you have to remember the definition of a derivative, the limit definition. So we've written it 3 ways at this point. They all kind of mean the same thing. In the definition of a derivative video, I wrote it as this way. Right? In the last video, I used H. It doesn't matter. Just using different variables, right? Sometimes I think this one's a little easier because I understand that I'm finding the change in X, or H is just like another variable, but I think you see this a lot. You can choose whichever one makes sense to you today. But I'll use this one for today. And hopefully you're realizing this is just a slope formula, right? y2 minus y1 over change in x, change in y over change in x, right? We're just taking the limit because we want our interval to be approaching 0, as small as it can be. So if you have a function, let's say f of x equals x squared, we can imagine what that looks like, right? But we need to find the derivative when x equals 3. So we need to find the slope of the tangent line when x equals 3. Okay, so you could try to graph it, estimate it, and all that, but we can find it exactly if we use these limit definitions up here. So let's use the change. I'm going to use the change in x one, this first one. So the limit as delta x approaches 0, let me make sure this isn't bleeding through, of f of x plus delta x. So x plus delta x squared. The function is x squared, so all I did was substitute that in for x. Take away the original function, x squared, all over delta x. Okay, I've just used that and substituted in this function. Now I need to expand that, because hopefully I can cross out some of these delta x's so I don't have a 0 in the bottom, right? That's what I'm trying to do here. So that would be x squared plus 2 delta x. I'm going to put x delta x so I don't get confused. And then plus delta x squared. I was going to write delta xx, but that's kind of like a lot of x's, so I'll put the x in there. Minus x squared over h. Okay, right away I can see this and this cancel out. Right? So what am I left with? I'm left with a limit as delta x goes to 0 of 2x delta x plus delta x squared. Oh, I did this thing, I wrote h. Whoops. Over delta x. That's why h might be better, because then you don't end up with all these x's. So maybe I'll do the next one with an h, and you can make your preference. So right away I can see this delta x cancels out with that delta x, and then I can take this squared off, right? So I have eliminated delta x from the denominator, which was my goal, because now I can just straight up plug in delta x as 0, right? So 2x plus delta x. Okay, delta x is 0, so this thing equals 2x plus 0, which means this thing is equal to 2x. Okay, so this is the expression, equation, formula, whatever you want to call it, that's going to give me the derivative of this function. Okay, so f prime of x equals 2x. But now they're asking me what's the value of the derivative at 3. Okay, f prime of 3 equals 2 times 3. It equals 6. That's the answer. So now we're evaluating limits in order to calculate the derivative, the slope at a point. So if you graphed y equals x squared, you would, if you went up to where x equals 3, the slope of that tangent line would be a positive 6. Okay? All right, let's keep going. Example 2. All right, so I'm going to use this limit definition now, this limit notation to evaluate this. So the limit is h goes to 0, f of x plus h. So 5x plus h squared minus 3x plus h plus 7. All take away f of x. So take away this thing. All over h. Now we're just going to simplify. Okay, x plus h squared is going to be what? It's going to be that, right? Just distributing that out. I'm going to get rid of this, parentheses. Okay, now let me just rewrite this. You can combine these steps, but I don't want you guys to get, because it does get long. Whew. Okay, what cancels out? Let's see. This and minus 5x. Oh, I see a mistake here. I forgot to distribute that negative, and this should be minus 7. So then now they cancel out. You guys let me distribute this negative in all wrong. This should be a plus. I only distributed it to the first one, those common mistakes, right? And I'm checking that because I'm like, that should cancel out, does it? Now it does. Plus 3x minus 3x. So I am left with all right, now cancel, 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 cancel. Now we are just plugging in. Did I mess up something here? Let me check my work. 10x h plus 5h squared minus 3h yeah. There's an, I have an error in my work and I'm trying to find it. So let's see. Oh, I just forgot to write minus 3. There it is. I didn't copy down the minus 3. I crossed out this h and I forgot about it. Okay, now let's plug in 0. So this thing equals 10x plus 5 times 0 minus 3. So this thing equals 10x minus 3. So f prime of x, the derivative, the equation to find the derivative is 10x minus 3. And they want us to evaluate it at -1. So f prime of -1 equals 10 times -1 minus 3, which equals -10 minus 3, which is -13. So there's your answer. Slope of the tangent line at -1 is -13. So I know the function is decreasing there too, right? Okay, let's try one more example. Example 3. If you want to pause, this might be a good time to pause, try it, and then come back and check and see what you get. Okay, so let's use the h this time again. So f of x plus h, so square root of x plus h minus f of x all over h. All right, so let's get rid of this thing up here, right? Let's do this. Let's multiply by the conjugate. Really, I need to set up my notation better. Because I need to show what I really need to do is rewrite all of this. So I'm not going to do it because I'm out of space, because I'm just skipping to the step. But really, when you write this here, you need to write this and then equals the limit of all this again times that. I just don't want to redo it, okay? So you can remember that when you're doing your notation. I'm just trying to squeeze it all in here. So now let's multiply this becomes a limit. As h goes to 0, this thing becomes of x plus h minus x, right? All over. What's left here? I'm just going to write h times x plus h plus root x. Okay? I'm just going to leave the h out there for now. I'm not going to deal with it. Now what can I do? Well, now I see that this is going to cancel out. And I also, so let's rewrite that. I won't do the next step. Okay, now I can see that those are going to come out, cancel out. So this is equal to the limit as h goes to 0 of 1 over root x plus h plus root x. Okay, so now I can go ahead and plug in the 0. Okay, so that comes out to 1 over root x plus root x, which then comes out to 1 over 2 root x. So f prime of x is equal to 1 over 2 root x. Okay, they want us to evaluate it at 4. So what's f prime of 4? 1 over 2 times root 4, which is 1/4. All right. So hopefully you're getting that. You just have to evaluate this limit, which is, there's a lot of room for algebra mistakes there. Just check it. And then once you get that part done, you shouldn't have this h in the denominator anymore, or the delta x, whatever you decided to work with, it should be gone. And then you can evaluate the derivative there. So, some notes about derivatives, some generalizations we can make. The derivative, the slope of the tangent line of an endpoint, we're just going to say is undefined. So, let's say you have this a, you have this b. Let me get a different color. Let's say you have this function like this. Right? At these endpoints a and b, it's undefined, because we can't make an interval approaching from the left and the right. Okay, that's one thing you can remember if you're ever stuck. So if you have a sharp, the other thing is if there's a sharp turn or a cusp, the slope will always be undefined. So if you have something like this, let's say here's point C, and your function goes like this, it's almost like an absolute value function, right? Here, then f prime of C is undefined. Also, let's say you have a function like, let me draw it first. Let's say you have a function like this. I'm gonna go. So there's your function. We can call these f of x. If you were trying to evaluate the function at this point here, say C, where you could see that the tangent line is going to be straight up and down, well, what's the slope of a vertical line? It's undefined. So this is also undefined. Okay, don't worry about this. Okay, your practice is online. Hopefully that's starting to make a little bit more sense. And those of you who already know the shortcut to evaluating into a derivative, you just have to hold on to this limit definition for a little bit longer, okay? Bye, guys.